Merhaba, ADF'ten yani otomatik yön bulucudan bahsedeceğiz bugün.
Hello, and welcome to this presentation on understanding ADF. In this short presentation, we're going to cover the basics of how ADF, or automatic direction finding, is used as a navigational aid. One of the very first radio navigation methodologies used fixed loop antennas that were tuned to commercial AM broadcast stations. The plane was then flown in a circle, or the antenna was
Burada havacılığın ilk başlarında ADF'i nasıl bulduklarını, nasıl kullandıklarını anlatıyor. Şurada gördüğünüz anteni fiziksel olarak döndürmeden istasyon yönünü bulmakta kullanmışlar.
rotated until maximum signal strength was received and a bearing or heading towards that radio station could be determined. Automatic direction finding is called automatic because these systems determine the direction towards the tuned station automatically, without the need to fly in circles or manually rotate a loop antenna. ADF was originally used to find commercial AM broadcast stations, but over time, special non-directional beacons were installed, and these NDBs supplemented and then largely replaced AM broadcast stations as navigational markers. Let's take a moment to explain the difference between ADF, automatic direction finding, and NDBs, or non-directional beacons. ADF is a navigational technique that uses signals from ground stations called NDBs.
ADF yani otomatik yön bulucu, NDB adı verilen yer istasyonlarından gelen sinyallere dayanan bir radyo navigasyon tekniğidir.
In other words, the transmitters are NDBs, and we find the heading towards these transmitters using a methodology called ADF. NDBs were once called homers because pilots used them to home in on a station. In fact, the FAA still uses the letter H in NDB category designations. An NDB is a very simple station that requires very little power and even less maintenance. Many NDBs have been in constant operation for decades. One other name you may hear associated with NDBs is compass locator. This is an NDB that's used in conjunction with the Instrument Landing System, or ILS.
Bu NDB'ler güvenilir, basit, düşük güç ve düşük bakıma sahiptirler. Bu yüzden onlarca yıldır sürekli kullanılıyor, çalışılıyor bunlarla. Bazen ILS ile birlikte bir NDB kullanılır. Bu durumda da pusula bulucu olarak adlandırılıyor.
ICAO defines the NDB frequency range as 190 to 1750 kilohertz, but in the United States, only 190 to 535 kilohertz is used.
Burada da NDB'nin otoritelere göre frekans aralıklarını veriyoruz.
Since frequencies above this are used by AM broadcast stations. Because of their low frequency, NDB signals can propagate beyond line of sight, either by skywave or ground wave propagation. For this reason, it's very important to positively identify an NDB before using it, especially at night. There are 4 defined service classes or ranges for NDBs. Note the H for Homer that we mentioned on the previous slide. Because of the importance of positively identifying an NDB, many ADF receivers have 2 modes that affect the receive range. The first of these is ANT-REC mode, which provides maximum sensitivity in order to detect and identify an NDB. However, in this mode, the receiver does not provide a bearing or heading towards the station. That is, the needle doesn't move. ADF mode has lower sensitivity, but it does cause the instrument needle to move and point towards the station. So given how important it is to positively identify an NDB, how do we do this? NDBs can identify in a variety of ways, including voice, Morse code, both, or neither. Actually, quite a few NDBs in the United States are in fact unmodulated. Unlike some other navigational receivers, ADF receivers typically don't have a flag that indicates no or poor signal reception. So if you're using an NDB, it's a good idea to listen to the ID signal the entire time you're using it. Since the signal is AM modulated, the presence of things like static, hum, interference, etc. can provide audible clues that the NDB signal may be unreliable.
NDB'ler ses, Morse kodu, her ikisi veya hiçbiri modüle edilmemiş NDB'ler aracılığıyla kimlik tanımlayabilirler. Amerika Birleşik Devletleri'nde çok nadirdir. ADF alıcılarının sinyal alımının olmadığını, zayıf olduğunu gösteren bir işaret yoktur. Bu nedenle NDB tabanlı navigasyon sırasında ID sinyali sürekli izlenmelidir. NDB-ID sinyalini dinlemek sinyalin güvenilmez olduğunu ya da parazitli olduğunu, uğultulu olduğunu belirlememize yardımcı olabilir.
NDBs are represented by their own symbol on sectional charts. In most cases, NDBs do not lie along routes or airways. Charts will show the NDB name, frequency, abbreviation, and Morse ID. Here we see Levy on a frequency of 350 kHz, abbreviated LE. Note that if the frequency is underlined, this means that the NDB has no voice capability and that the ID is in Morse code only. We can also find the same information, including lat long and distance heading to the field, in the airport facilities directory. Although not common, there are still some airways or routes in the United States that are based on low and medium frequency navigational aids, that is, on NDBs. All of these are found in Alaska, with the exception of the G13 airway on the North Carolina coast, near the site of the Wright brothers' historic flight. That said, NDB-based routes are still used in many other parts of the world. NDB approaches are still being used in the United States, but their popularity is decreasing. In fact, in 2011, only half of all airline transport pilots flew any NDB approaches, and this number has decreased rapidly since then. Nevertheless, flights from the United States to either Canada or the Caribbean may require an NDB approach at some airfields. One last historical note. A lack of pilot proficiency with NDBs was cited as the cause of a crash in 1996 that killed U.S. Commerce Secretary Ron Brown and 34 other passengers. But how exactly does ADF find a direction towards the NDB without needing to physically rotate a loop antenna? ADF receivers actually use two antennas, a loop antenna and a sense antenna. The sense antenna is non-directional, that is, it receives equally well in all directions, and the loop antenna, as we know, receives better in one direction than another. In most modern aircraft installations, these two antennas are integrated into a single package, although you may see other form factors, such as fin-type antennas.
ADF alıcıları iki anten kullanıyor. Loop ve sense, bunlara yönlü ve yönsüz diyebiliriz. Yönsüz olan her yöne eşit derecede iyi alıyor. Yönlü olan da bir yönde diğerlerinden daha iyi alıyor. Ama modern uçaklarda bu antenler tek bir pakete entegre edilmiş ve diğer modern form faktörleri arasında tel ve yüzgeç tipi antenler bulunuyor.
On the ground side, NDBs and their antennas come in a wide variety of form factors. The two most common of these are the symmetrical T-wire antenna, suspended on both ends, and the top hat style antenna, typically mounted on a sectional tower. And of course, non-directional beacons have a pattern that's non-directional. One of the big advantages of ADF is that it's very easy to use. Just tune to the station, and then set the receiver to ADF mode. The ADF needle then starts pointing towards the station. Some ADF receivers only show direction relative to north, whereas others will show direction relative to the current aircraft heading. And lastly, remember that because ADF does not have an error or fault flag, audible identification of the beacon is very important whenever using ADF for navigation.
ADF'in bir avantajı da kullanım kolaylığı. Burada bundan bahsediyor aslında. Çünkü sadece NDB'yi ayarlayarak ADF iğnesinin istasyona doğru işaret ettiğini görebiliriz. Bazı ADF cihazları yalnızca kuzeye göre yön gösterir. Bazıları da uçak yönüne göre yön gösterebilir. ADF enstrümanlarında hata ya da hata işareti bulunmadığından işaretin hala alındığından emin olmak için kimliği dinlemek önemlidir. Doğru işaretin hala alındığından emin olmak için kimliği dinlemek de aynı zamanda önemli.
So what kind of accuracy can we expect from ADF? Usually accuracy is plus or minus 5 to 10 degrees. Some of this depends on the receiver or the antenna, but there are several other factors that affect ADF accuracy. First, as we mentioned earlier, signals from NDBs can travel long distances, especially at night, and this can create interference from distant stations. A more serious issue is something called the thunderstorm effect, which causes the ADF needle to point towards a thunderstorm. There are also some less serious effects, such as the shoreline effect, where the bearing changes when crossing the coastline at an angle, and various terrain effects due to multipath from mountains, etc. The ADF needle can also become unreliable or unstable due to static buildup when flying in precipitation, or due to RF interference from electrical devices like alternators, strobe lights, etc.
Burada ADF'in doğruluğunu azaltan bazı etkilerden bahsediyoruz. Gece etkisi, fırtına, kıyı, arazi ya da yağış gibi şeyler ADF'in doğruluğunu etkiliyorlar.
When you combine these with somewhat lackluster accuracy in general, it should be clear that ADF can't really be used for precision navigation. What does the future hold for NDBs? Although NDBs are still widely used in the rest of the world, they are gradually being phased out in the United States. NDBs are low cost and reliable, but as we've seen, they suffer from a number of drawbacks related to propagation at their operating frequencies. On sectional charts, decommissioned NDBs are indicated by hash lines through their frequency. The most recent FAA en route transition plan anticipates that in the United States, NDBs will be completely phased out by 2030.
NDB'lerin geleceğinden bahsediyoruz burada da. Hala dünyanın geri kalanında yaygın olarak kullanılıyorlar. Ancak Amerika Birleşik Devletleri'nde kademeli olarak aşamalı hale getiriliyor. Çok düşük maliyetli ve güvenilirdir. Ancak frekans ve yayılma ile ilgili birçok dezavantajdan müzdariptirler. Yakın tarihli FAA rota geçiş planı 2030 yılına kadar Amerika Birleşik Devletleri'ndeki NDB'lerin aşamalı olarak tamamlanmasını öngörüyor.
Let's summarize what we've learned. First, automatic direction finding, or ADF, was one of the earliest radio navigation methods. It originally used simple loop antennas to find the bearing or heading towards commercial AM broadcast stations. Over time, special non-directional beacons supplemented and then replaced AM broadcast stations as navigational markers. Remember, ADF is a method by which we locate NDBs. ADF is very easy to use. We just tune to the NDB frequency, make a positive audio identification, and then use the ADF arrow to view the direction towards that station. Note that ADF accuracy and reliability are not particularly high, and this is part of the reason why NDBs are slowly being phased out in the United States, although ADF is still used in many other parts of the world.
Otomatik yön bulma. Yani ADF'ler radyo navigasyon yöntemlerinde ilklerden biriydi. Başlangıçta AM yayın istasyonlarına doğru yön bulmak için kullanıldı. Daha sonra ADF kullanarak yönsüz işaretçiler ile değiştirildi. NDB frekans ADF'i kullanabilmek için öncelikle NDB frekansını ayarlıyoruz. Daha sonrasında istasyonu pozitif olarak tanımlıyoruz. Sonrasında da ADF oku istasyonu işaret ediyor. Kullanım olarak çok basit. Ancak ADF doğruluğu, güvenilirliği çok yüksek değil.
This is our presentation on understanding ADF. Thanks for watching.
Bu kadardı sunum. Teşekkür ederim.